Hey, fifth grade, how's it going? Teacher Joseph here. Hopefully, you're doing well. Today is Tuesday, August 18th, 2020. Today, we're going to learn about and classify properties of angles and triangles. So, let's jump right in. Today, what we were doing was watching two different videos, which are from Math Antics, really great series of math videos, just to really learn about the vocabulary of the topic that we're going to learn today, which is all about angles and triangles. Today, we learned about what a straight angle is. We learned about different line segments that can be classified as parallel or perpendicular, or even when lines cross what they're called, which is called intersecting lines. Now, perpendicular lines and parallel lines are two very important concepts when talking about angles and quadrilaterals, okay? Triangles as well. Now, when we intersect lines, we can calculate the different measurements of the angles in different ways. It's very important that we also understand that when we're looking at different angle measurements, these angles can be either large angles or small angles. And the larger you get, the larger the quantity is going to be, the degrees, we should say. Okay? These angles can be classified in several different ways. And we can even have an angle that's considered a right angle. Now this right angle is measured by 90 degrees. So there's different angles that are either smaller than 90 degrees or larger than 90 degrees. For example, an acute angle would be an angle that is less than 90 degrees. Okay, you can see this 45-degree angle is called an acute angle. We practiced showing this with our hands in class. A right angle is exactly 90 degrees. It makes a square. And then an obtuse angle is much larger than 90 degrees. Okay, so you could have an angle that would be up to 130 degrees, or maybe even 179 degrees. That would be an obtuse angle. Okay, there's different types of angles, and the biggest ones that we're going to look at here in fifth grade are acute, right, and obtuse. Okay. You also have a straight line or a straight angle which measures 180 degrees. So let's take a look at this first example. Take a look at that. What do you think? Would that be straight, right, obtuse, or acute? Yes, this is a straight angle, right? It doesn't measure 90 degrees. It doesn't measure larger than 90 degrees. It's actually 180 degrees total. Let's take a look at this next one. It says classify each angle as acute, obtuse, right, or straight. What would you classify that angle as? If you said acute, you are correct. That angle is acute. It's much smaller than 90 degrees. Let's take a look at these examples. This might be a little bit more difficult. The question says, which figure illustrates that the two angles are not parallel given the two angle measurements? Well, here we have opposite angles. One of them is interior, one of them is exterior, and they both measure the same. Here again, we have two angles. Both of them are interior angles, and they both measure the same. Here we have an interior and an exterior angle. Okay, these are complementary angles, and they both measure 35, but I'm not really sure about that one measurement right in the middle, that interior angle. And then we have opposite angles, 42 degrees and 138 degrees. I think taking a look at this problem, letter C is the one that shows non-parallel sides, because these two added together, if we wanted to make a straight line, wouldn't add up to 180 degrees. Let's take a look at another example. Number 5. What is the name for the angles which are between 90 and 180 degrees? Well, I know that a right angle is 90 degrees, and I know that an obtuse angle is 180 degrees. So this one must be, if it's between 90 and 180, it must be obtuse, I think. Let me just look back to make sure that that is correct. We had a couple more. Let me see. Exactly 180 is straight. Reflex would be between 180 and 360. Okay, so this is an obtuse angle. Yeah, it'd be an obtuse angle. Okay, let's take a look at another question. Now, the next couple of questions that we're going to be doing all have to do with triangles, okay, which was the second video that Mr. Joseph wanted you to look at. This Math Antics video talks about different types of vertices, how they change, and classifying triangles based on where those vertices are, okay, the length of the side and the length of the angle. So if we take a look at that video and then you watch it till the end, you'll be able to understand that there are different types of triangles, like equilateral triangles and isosceles triangles. The difference between an equilateral triangle is that all three sides of the triangle are the same. They measure exactly the same. Versus an isosceles triangle where only two sides measure the same. We can take a look at these and also classify them by angles, right? We have acute, right? Acute triangles, which have all three triangle measurements. The angles are different, right? And then we have a right triangle, where only one of the angles measures 90 degrees. And then we have obtuse triangles, just like the angles, right? We have one of the angles that is measuring more than 90 degrees. If we take a look at this question, it says, what type of triangle is this? Well, I know it cannot be an equilateral triangle because equilateral triangles have all three sides that equal the same. Okay, is it a scalene or an isosceles triangle? Well, let's take a look at the difference between scalene and isosceles. It says a scalene triangle is a triangle in which all three sides have different lengths. So if we look at this, I can tell that with those lines on the side measurements, two of them are the same. So this cannot be a scalene triangle. It has to be an isosceles triangle. Okay? So this is an example of an isosceles triangle. All right. Different types of triangles have different angle measurements, just like we said before. An acute triangle will have at least two measurements that are acute, right? Right triangles have at least one angle measurement that is right. Obtuse has at least one angle measurement that is obtuse. Okay, so we can classify them by their angle measurements or their sides, right? So here's another example, more examples inside the video of those different types of triangles. Let's do this example right here. This time we're classifying the triangle from its measurement of its angles and its sides. So if you take a look at the triangle, you have 23 degrees, 31 degrees, and another degree measurement. Now, we need to know that triangles always add up to a magic number 180, whether it's this first example that you see here. Okay, this is one, A, B, and C all equal 180. Here's another example right here. It has 91 plus 33 plus 56 equals 180. And here's another example. 94 plus 36 plus 50 equals 180. And a third example, we have 48 plus 109 plus 23 equals 180. So it doesn't matter the measurements of the angles, but they always need to equal 180 if you add them up, okay? So if we have this one, 23, 31, and what? Well, let me just try to see if I can add those up just to show you. Let me see, 23 plus 31 equals 55. Now I know that this other angle measurement is going to equal 180 minus 55. In other words, 55 plus that angle measurement is going to equal 180. So I can take 180 minus 55 to get my angle measurement right there. What is 180 minus 55? Well, let's see. 10 minus 5 is 5, and 7 minus 7 tens minus 5 tens equals 2 tens, 125. This one is 125. Well, since they're all different angle measurements, I know that this cannot be acute. And it cannot be right because it's not 90 degrees. So it's got to be obtuse. Now, since all of them are different angle measurements, each one of these is different, that also means that all the sides are going to be different too. So I know that this cannot be isosceles. Otherwise, two of the sides are the same. So it's got to be obtuse and scalene. All right? This is a little bit more difficult, especially for our first lesson, but just getting you guys to understand that we can classify triangles by their angles and by their sides. So let's take a look at just one more example. Which type of triangle would this be? Ooh, I see that magic square right there. That magic square tells us that this triangle is a certain type. Is it obtuse, right, or acute? Well, acute isn't even one of our choices, so it's got to be right. So it's either B, C, or D. Now, if we take a look at the angle measurements, I know that 3, 4 are both different. So it cannot be isosceles. So it's either got to be scalene or equilateral. Now, since this measure of this line is different than this one, it can't be equilateral, otherwise those sides would be the same. So it's got to be right and scalene. It's got to be your answer right there. All right, cool. Good job, boys and girls. This just gives you a little bit of an understanding of different types of angles and triangles. Here's one more question. Find the measure of the missing angle. Well, you should already be able to do that because we know how to find the angle measurement from 180. If we know this is 40, and we know this square equals 90, we can take 90 plus 40, which equals 130, and we can take 180 minus 130, and that's going to give us 50. So the angle measurement right there is going to give us 50 degrees. There's your answer right there. All right, boys and girls, so that's the end of this video. If you wanted to check this out a little bit more, what you could do is go to brainpop.com and you could play this little review game if you want to. Just check with Mr. Joseph to see if you can get the username and the password. It's a pretty neat game. It just talks about different types of triangles like scalene or isosceles. Okay, so let's just do a couple of these. It says, two interior angles of a scalene triangle measure 45 and 110 degrees. The third angle measures, well, 45 plus 110 is 155. And 180 minus 55 is, what is that? 180 minus 55. That would be 125. Oh, but that's not one of our, nope, sorry, just 25. Let's try that. Did we get it right? All right. Which of the following is an equilateral triangle? Well, it can't be the letter A. That's right, but it can't be. Let's see. Let's try D. An isosceles triangle has a perimeter of 36 centimeters. The short side measures 6 centimeters. Each of the longer sides measure. Tell you what, we're gonna save some of these problems for next time. We're gonna continue working with isosceles and scalene and those types of triangles for another date. And I do appreciate you checking out the class today, and hopefully we will see you soon. So we'll see you on Friday. See you later, boys and girls.